Hi students, this question is about wedge. The question is given here: a smooth wedge of a mesh 4 meter rest and on a small horizontal surface. A particle of mass is placed here. You can see that, and so particle of mass is placed on the smooth inclined surface. It's going to be theta, and the system is released from the rest. So show the separate diagram, the forces acting on the wedge and on the particle. So this question I already drawn it for you. I'm going to show it to you now. So this is the particle, the force acting downwards because it has a mass of m. So it's going to drop mg, and the normal force is r here, and here the wedge, it is acting horizontally here. The force is s, and also you can see the normal forces are here. That's the first part of the question. The second part of the question, the particle moves with acceleration p related to the wedge, and the wedge moves with the acceleration of kp cos theta. So you have to find the value of k, which is this one, and also you have to show the p is equal to 49 sine theta divided by 4 plus sine square theta, or you can say 49 sine theta over 4 plus sine square theta. Okay, to do this question, we need to consider three things. First one, you need to consider parallel to the plane. Second one, perpendicular to the plane. The third one is horizontal for the wedge. Okay, so first we consider the parallel to the plane. If you look at the diagram, the particle is going to move down. At the same time, when it's moved down, the wedge actually going to move to the right. Okay. In the first part of the, in the question they're given to you, the acceleration of the wedge is going to be kp cos theta. I'm not going to write kp cos theta all the time. At the moment, I'm going to write let a is equal to kp cos theta. So instead of kp cos theta, I'm going to write a. So I'm going to divide that acceleration in both directions, parallel to the plane. And if you do that, then if you look at that, that is going to move this way. So if this angle is same as that angle, therefore this is going to be a sine theta, and this is, so a sine theta, that's going to be, sorry, a cos theta, not sine theta when you come, sorry, it's cos theta, and that is going to be a sine theta. Therefore, the resultant of this one is going to be P minus, okay, A cos theta. So this way and that way, okay. So if you write the equation for using F equal to MA, right? So that is going to be mg sine theta. So the mass of this particle is going to move this direction. So that's going to be mg sine theta. So mg sine theta is equal to, it's only plane, so we don't need to worry about other things. So m, that is a mass, and a is acceleration, is the result of that. P minus a cos theta. That is equation number 1. Okay. Now we can do perpendicular. If we do that, perpendicular to the plane. So this is a parallel to the plane. The next one is going to be perpendicular to the plane. Right. So in this case, we can say that one is going to be mg cos theta, and the normal force is acting this direction. That's going to be the R. So I'm going to write R equal to m, that is, and then if you look at the A acceleration to the perpendicular, that's going to be A sine theta here. A sine theta. I have to remind you A is equal to Kp cos theta. In this case, if you cancel this m and this m, then you will end up only G sine theta equal to P minus A cos theta. Okay, I can't do that here because the R don't have an M, so I'm going to leave it as that one. So that's going to be 2. Right, the third part we had to do for horizontal for the wedge only. So the wedge is only moving, the horizontal is not moving vertically. So it's moving to the right. So I put A and they have acceleration of A. So we already knew that A is equal to Kp cos theta. So if you look at, so I divide this the force R into horizontal and vertical. So that is going to be, if I divide this one, that's going to be R cos theta. If I divide it to first one, that's going to be R sine theta. Okay, so vertical and horizontal forces. So if I write this, so it's only moving in the horizontal plane. So R, that is going to be that one, R sine theta is equal to, you know that one is going to be, one as a 4 mg, so that's going to be mass 4 m, that's a mass, and the acceleration A. Okay, so that is going to be the third equation. So now we got 3 equations. We'll try to show a question for the first part. Okay, I have written all 3 equations which we have already done. So we are going to do, actually what I'm going to do, I'm going to substitute equation this one into equation 3. Okay, so what's happening here, R equal to, so instead of R here I'm going to substitute that value. So mg cos theta minus ma sin theta, and you had to multiply by sin theta again, equal to 4 ma. In here, I write here, sub 2 into 3. So that's what I did here. So from here you can see the m is common for both sides. So I'm going to cancel that, cancel that, cancel that. So you will have g cos theta a sin theta bracket sin theta equal to simply 4a. Therefore, but we know a equal to kp cos theta. That's given, huh? So I'm going to put that value back into here, where A is. So G cos theta minus, I'm going to write this one here, A, that is going to be, what's that? Kp cos theta. Then we have here another sine theta. So I have to keep the sine theta. And outside also I have another sine theta equal to 4 A is equal to Kp cos theta, Kp cos theta. Okay. Now you look at that. We have a cos theta here, we have a cos theta here, and we have a cos theta. So it can be cancelled. So what will we have here? Simply G minus Kp sine theta, and again outside sine theta, and equal to 4 Kp. Okay, so that is, we can still, that's a question 3, equation 3, right? So because we substituted equation 3. Now we can open the bracket. G sine theta minus Kp sine square theta equal to 4 Kp. Okay. Now upload back whatever we have done so far. That is going to be G sine theta minus Kp sine square theta equal to 4 Kp. So what I'm going to do now, you know the equation number 1, G sine theta equal to P minus A cos theta. So what I'm going to substitute, this is still equation number 3. So sub 1 into 3. So instead of G sine theta, I'm going to write P minus A. You know A is equal to Kp cos theta. Okay. So P minus, instead of A, I'm going to write that one. So Kp cos theta, and another cos theta here. So that's going to be cos square theta now. Okay. Then what's happened here? Minus Kp sine square theta equal to 4 Kp. Now you can see we have P here, P here, P here, P here. So I'm going to cancel all the P's. So that will be 1 now, right? So what we'll have here, 1 minus K cos square theta minus K sine square theta equal to 4K. So next thing I'm going to do, I'm going to use a trigonometric identity. So 1 minus, I take K as a common factor, K in this up. So it's going to be cos square theta plus sine square theta equal to 4K. Okay. Sine square theta plus cos square theta equal to 1. You should know that is the trigonometric identity. So I'm going to write this, that is going to be 1. So 1 minus K into 1, that's simply K, equal to 4k. Therefore, if you take k other side, that's going to be 1 is equal to 5k. Therefore, k is equal to 1/5. So that's the first part of the answer. Second part of the question. So for that particular question, I'm going to use the equation number 1. So g sine theta equal to p minus, I know a is going to be kp cos theta. P cos theta and another cos theta, so that's going to be cos square theta. So in here, I'm going to replace this k with 1/5 because we already worked out in the first part of the question k is equal to 1/5. So I'm going to write underneath a is 5. Okay. So we can make the denominator equal. So I'm going to say, for an example, if I write this one over 1 and this one over 1, I can multiply this one 5, this one 5, therefore that's going to be 5, and that's going to be 5. So now you can see the denominators equal. So I can cancel all the things. So you can cancel this now. That will end up 5g sine theta equal to 5p minus p cos squared theta. Okay. So, you know, sine squared theta plus cos squared theta equal to 1. Okay. So, in this case, no, we may not need that, but write it down. So, I can write this one is equal to, don't need that. Sorry, don't need that. So, I can rewrite this one is equal to p is common, 5 minus cos squared theta. That is equal to that one, yes. Therefore, 5g sine theta equal to p into 5 minus cos squared theta. So from here you can see p equal to 5g sine theta divided by 5g sine theta 5 minus cos square theta. Okay. Now if you look at that, sine square theta plus cos square theta equal to 1. Therefore, cos square theta equal to 1 minus sine square theta. 5 minus cos square theta. So 5 minus, instead of cos square theta, I'm going to write 1 minus sine square. Open the bracket, 5 minus 1, minus into minus plus, sine square theta. 5 take away 1 is 4, 4 sine square theta. So, and you know, g is equal to 9.8. Therefore, 5g equal to 9.8 multiplied by 5, that's going to give you the answer 49. Okay, so P is equal to 5g, that is going to be 49 sine theta, and divided by, I already worked out that one as 4 plus sine squared theta. So that will be the final answer they ask you to prove. Thank you. I know it's a very long video. If you like my video, please subscribe and share it. And also if you press the bell button, you will get your next videos. Thank you.